Founder's message, take one. Hi, I'm Brent Constantz. I founded Blue Planet in 2012, recognizing the scale of the global CO2 problem on Earth and understanding what the distribution of CO2 was and carbon on the planet. We're concerned about the atmospheric levels of CO2, where there are about 750 gigatons, that is 750 billion tons of CO2 in Earth's atmosphere, which is about 80,000 feet thick as an envelope around the Earth, in the gases, at about 400 parts per million CO2 concentration. There's another 4,000 gigatons in Earth's biosphere, all the plankton in the oceans and the rainforests, etc. And another 40,000 gigatons in the hydrosphere, the oceans, the rivers, the ice caps, and lakes. However, in the lithosphere of the Earth, there's approximately 50 million gigatons of carbon. And almost all of that carbon is actually in the form of limestone, as we're familiar, like the Great Barrier Reef or the White Cliffs of Dover. It's not in coal or hydrocarbons, but in limestone. And what's important is that other than water, rock itself is the largest commodity on the planet. There's over 55 gigatons of rock mined every year and moved and consumed and paid for around the planet. And a significant amount of this is limestone, which actually contains most of Earth's carbon. Now, concrete is the most used building material in the world. And it's used ubiquitously all around the world in every type of country, rich and poor, for example. And 3/4 of concrete is actually aggregate, which meaning sand or gravel, which comprises about 3/4 of concrete. And there are over 55 gigatons, 55 billion tons of rock mined every year. And transported, used for things like mostly concrete and asphalt and road base. And these mines are in remote locations. So there's a high cost and CO2 footprint to mine the rock and bring it in to where it's used. And almost all rock mining is open pit mining, which is the most environmentally destructive type of mining. I realized that we had technology available to convert the CO2 that humans produce, which is on the order of almost 40 gigatons a year, 40 billion tons a year. That's coming from power plants and industrial plants and mainly from transportation, and convert it into limestone the way it happens naturally in the formation of limestone. And this is carbonate mineral formation akin to the native biomineralization process seen in marine organisms. And this is fundamentally different than what's been done over the last decades with carbon capture, where it is purified at high cost and energy, so it can be liquefied and disposed of as a waste underground. Limestone is the skeletal remains of marine organisms like corals and lobsters and clams and calcareous plankton, as we see, for example, in the White Cliffs of Dover. The 70% of the aggregate used today in concrete is limestone. So there's an established pathway for limestone to be used in concrete. It's not a new idea. Now, limestone is primarily calcium carbonate, which is 44% by mass CO2. So if I have a ton of limestone, I have 440 kilograms of CO2 permanently sequestered in that limestone that will not return to the atmosphere. Um, Now, much of the aggregate used is funded ultimately by governments. And by sequestering CO2 as limestone and using it in concrete in government-funded projects, it shifts the strength and the power of CO2 mitigation to all the countries in the world. That is, countries can use their procurement power in their infrastructure projects to have a procurement preference for carbon sequestered limestone. So this is something that can be effective in rich countries that may also have government subsidies for CO2 abatement. But it can also be useful in most of the world, which are poorer countries that will never have the ability to have government subsidies. So this is a truly global solution of converting CO2 into limestone to be used in concrete, funded by governments, with dollars they're already spending for procurement of rock, which otherwise would have come from open pit quarries. Now, at Blue Planet, our business model is based on the profits from selling limestone with no government subsidy, allowing for a global solution. Now, with 1 ton of CO2, we manufactured 2.5 tons of limestone. And within a cubic meter of concrete, it would typically contain roughly on the order of 2 tons of sand and gravel aggregate. And that would allow us to sequester approximately a ton of CO2 per cubic meter of concrete. So this takes concrete from an environmentally harmful material, which usually has a large carbon footprint, to where we're sequestering the CO2. But now we're doing it in a profitable way. We're not disposing of it as a waste. And we're doing it in a market that has more than the capability to accommodate mankind's CO2 on a sustainable, both technologically and economically ongoing basis. And it changed the way we think about the most common building material, which is concrete. Now, the more concrete used in a structure, the more CO2 we're sequestering in the built environment. And allows architects and structural engineers to think differently. It provides a mechanism to really address mankind's greatest challenge, which is climate change, in a significant way. So through the global commercialization, through partnerships with large industrial firms across the world, Blue Planet will be able to realize and commercialize this solution globally in a relatively short time, because we're coming into an existing product system, which is the largest commodity on Earth. We hope you learn more about Blue Planet and hope you gain an appreciation of the significant impact we believe our solution will have. Thank you very much.